Hey guys, welcome back to the channel. Waiting on the parts for the Zenith, and I'm also waiting the parts for the old Hewlett Packard 405 CR voltmeter, digital voltmeter. So I figured that while I'm doing this, and I'm kind of bored out in the shop, that we take a look. Let's look at this modulation issue with this this old signal generator here that I've got here. Right now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 screws in this cover that I've got to get to. So that's what I'm doing right now, just taking all these screws off. And they do give you this handy little Allen wrench here that's probably, what, 10 inches long. So that's what I'm doing. There's 4 of them on this side. There's just a bunch of flathead screws over this side and some right here on the top. This cover comes off. When that cover comes off, then I'm going to get the schematic out and I'm going to pull some tubes and I'm going to check them, because I have a feeling we'll probably just have a weak tube, and that's why the mod is doing what it's doing. So anyway, that's what I'm doing on this. So I'll get that cover off, I'll get the schematic, figure out what tubes is associated with this, and then I'll put them on the checker, and then I'll report back when I get that done. And watching me take screws out, covers off and all that is just kind of pointless. I mean, if you want to work on one of these, if you need to be told how to take a cover off, then you don't need to do it. Not trying to be ugly, I'm just saying. Anyway, I'll be back in a few minutes. Alright, 20 something screws later, cover's ready to come off this bad boy. There it is, ladies and gentlemen. There is the shield, and here's all the screw holes here. So what is that? 1, 2, 3, 4. That'll be 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Let's see, 18, 19. Let's see, 20, 21, 22, 23, 24. Yeah, 26 screw holes or screws, just to get that cover off. This is where the RF section is here. This is where all the business end of this rig is right here. You got 2 parallel tuning gangs right here, which is kind of no man's land. You don't really want to get in there and mess with that. Here's the old filter cap that I replaced by external capacitors. I didn't restuff that one. Can you believe it? So what I have to do now, these tubes, I got to get the schematic out. I got to get my manual out. It's one of these I changed and I need to replace. Oh, I left a capacitor in here. I missed one. Anyway, I got a 6AW8 that I replaced in here, but I bought a Hewlett Packard branded one to replace it with. I got to remember which one that is. But anyway, let me get the manual and see which one that I want to start checking. So let me get all that and I'll be back. Okay, in the interest of shaky cam prevention, I went ahead and put the camera on a tripod, pointed it at my screen here. But on that 606A signal generator, right here is the let me see here. I believe this right here is the the RF level right here, and it goes into a 6AW8 differential amplifier and also a 12AT7 cathode follower. So we'll be checking this tube here, V7. We'll be checking V8, which is a 6AW8 differential amplifier, and make sure you can see that. A V6 to 12B4A modulator. And let me scroll up a little bit. If you can see it, making sure you can, because I can't see the screen. The 6CL6V3 RF amplifier. So we'll be checking this tube right here, these two, V3 and V4, 6CL6, 6CL6, there's 12B4, V6, V7, which is a 12AT7, and finally V8, which is a 6AW8 differential amplifier. So we'll be checking all of those next on the Hickok 600, and we'll see what we can find. So I'll be back. Okay, I'm not sure how I want to compose this shot. I guess I don't want to just sit here and pull a tube out of this, stick it in here, and you guys are sitting over there. But then again, I'm thinking if I had somebody in here with me, you know, right beside me, they'll be sitting over there watching me from this angle here. I'd be pulling the tube out of this, you know, setting up the dials and everything, and then testing the tube, and then saying wah, la. So I can do it that way, or I can just point the cotton picking camera at the meter and like, ooh, wah. But you know what? I don't want to do that. Matter of fact, I got to turn the camera just a little bit. So you basically are going to see, and we're just going to talk. And I got to make sure that I'm not in the way. You know, my gut, I really need to do something about this spare tire. So, but I like eating. Now then. Alright, so, alright, first things first. Here's a list of the tubes right here: V3, V4, V6, V7, V8, the 6CL6, 6CL6, 12B4, 12AT7, and a 6AW8. And I went ahead and wrote down the values to preset in my tester, my 600A. And then we'll go ahead and test them. Pull each tube, and I'll mark over here. Whoop, premature there, wasn't it? I'll mark whether it was good, bad, or weak on here, and we keep a record of that as we troubleshoot this thing a little bit further. But I honestly believe it's one of those tubes are weak and not able to keep up. And that's why it's affecting the modulation like it is. Anyway, first one we got to find is V3. V3, here's V1, V2, V7, 6, 8, 4, 3. Here's V3 right here. 6, Charlie Lima 6. Phone ringing. Sorry about that. I had some family matters on the phone I had to deal with. Okay, I've checked V4 and V6. I'm sorry, V3 and V4, which is the outputs, the RF outputs, the two 6CL6s, and they check super strong, almost like a brand new tube. I didn't look at the day code, but it doesn't matter. So the next one I'm checking is V6, which is the 12 Bravo 4. It's in the tube tester right now. So let's go ahead and set the line adjust on this thing. Line adjust is good. Do a short test, no shorts. And double check the bias and English settings 50 and 90. Should have a gain of 6500, but I'm not checking that. I'm just looking at replace good. So here we go. It's in the good. Needle's running about between the G and the O on the scale there. It's staying good, but let's do what the let's look at the conductance of this thing. So it's expected to be 6500. So there's 3 little dots on the English scale on these 600As. One of them is corresponds to your meter here. There's a 3000, a 6000, a 15. And these 3 dots correspond to that. So since we're expecting, or it says ideally the tube should have a conductance or a gain of 6500 or a mutual conductance of 6500, we'll set it on the 15,000 scale, which means we'll read this bottom scale. So let's press the GM button again. It's actually measuring 5,000, 6,000, a little over, right at 6,000, so it's slightly weak. I don't think there's a problem there. We're going to write this down at 6,000. So the 12B4 is good. It's a little aged, but I don't believe that's the problem. So we're good there. Now sure all that gets put back in like it should. So the next one down is going to be V7, which is the 12AT7. So I got to find it. Here it is, right here. Excuse me. Hope y'all didn't hear that. This is 12AT7, not an AX. You know my feelings on 12AX7s. Anyway, the 12AT7, it's filament of 12.6. We set this up for EV. There's going to be trial number 1, so EV7608. So EV7608, then the bias of 10, and then 85 for the English, and we're looking at a gain of 4,000. Set. So this is going to be the first trial. This 12AT7 is a twin trial tube. So let it build up a little bit. You know what? I probably plugged the tube in. I wondered why why didn't y'all tell me that? I knew the line adjust was acting kind of weird. Boy, sometimes I don't know about me. Anyway, tube is warming up. I was kept looking at that tube like, wait a minute, what's that doing over there? I'm totally losing my mind. Okay, here we go. Let's check it for shorts. No shorts. Well, let's check it. Yeah, and it's alright. Again, it's right between the G and the O. Check's good. No shorts. So let's gains 4,000. So we'll put it the red dot here on 6,000, and we'll check it again. And we will look at the middle scale here. It's showing about 3,500. So this one's checking just a slightly bit low. It should be up here, and it's checking down here. So that's okay. I'm going to put try 1, 3K. Let's check the second triode. It's going to be EV2103. So change this back to 21030. It's going to be the same bias setting. So let's check it. As a matter of fact, we'll do this number first, which is the shorts. Alright, push the test button again, and this one shows a little bit stronger on that side. This one here is measuring still, let's see, 2,468. Right, 246. 3,700. It's closer to 4,000 than the other one. So we're just going to write that down. 3.7K. Again, it's a little bit of imbalance in that tube, but I don't think that's enough to bother it. Running out of things to go wrong here, guys. Alright, so the final tube is the 6AW8, which is going to be V8. And that one is going to be right here. This is the one. That's the one that come from my stock. That's the one that needs to be replaced. Alright, but let's go ahead and check it. Let's go ahead and set it up in the machine. Being a 6AW8A, that should be a 6.3 volt filament. So we'll set it again for EV7986. So EV79986-3, and then the bias of 10 where it is, and then 88 is going to be, that's right about where it should be. So we'll do P4, and the transconductance should be 5,000. What it says, I'm just the RCA tube that came out of my stock. Lord knows how good it is. Hopefully we'll find a problem there. Line test is just about where it needs to be. Adjust it just a little bit. Check it for shorts. Alright, let's check the gain on it. It's taking a little while to warm up. Yeah, it's about to make it the question mark. Yeah, look at there. Question mark. Right there. This gain should have a gain of 5,000 and this reading 2,800. Well, I didn't expect that. Alright, well, let's see what the other half of it is. 2301. Might have found our problem here. 23019. Let's check it again for shorts. No shorts. 1578 on there. Check it again. It's showing in the question mark range. This should have, yeah, it's supposed to be 2,500 GM, and it's reading 1,600. That tube is weak, and I'm going to call it bad. Well, I'll be jiggers. There you are. That may be our problem with our mod. So I have a replacement 6AW8 right here that I bought off eBay, marked HP. I tried to buy an HP tube for it. So let's check this tube. I think I checked it and it checked okay. But I don't remember. That was like yesterday. Oh God, it's made for Hewlett-Packard by RCA. I think I got a whole caddy full of these things. Anyway, let's power it back up, check it. Letting the line test. Line test is good. Oh my gosh. I don't know what I did. I don't know why I did that, y'all. I honestly don't. Okay, so it's coming up now. It's showing, let's see, 15, 16, 17, 18 and a half. Should be measuring 2,500. It's doing better than the other two, but it ain't what I expected. Huh. Yeah. May have to go back in my tube caddy and find a better tube. I swear I checked this tube. Should reset all this stuff. 1088. Alright, here we go. That one checks pretty good. It actually should be 5,000 and it's measuring 51 and a half. That one's good. Let's double check the other one. Go back to 23019. Reset it for 1578. In fact, I'm just going to put it, well, I tell you, let's put it on the good bad setting right now. Then we'll come back to the actual transconductance. So it's showing a little better, showing below the G here. So let's put it on 3,000 to see what its actual dynamic mutual conductance is. We're still measuring below 2,000. It's measuring 1,800. So that section of that tube, not the best in the world. So let me dig under in my tube caddy, see if I can find a tube with better specs. I'll be back. Alright, I dug through my tube caddy and I found 3 more 6AW8s. Says it's a tongue sole. This one says it's a RCA. This one says it's a GE. Okay. Alright, let's go for the GE, shall we? It's all taped up, all nice, and I'll break the tape seal. Place your bets now whether this is an actual GE in here or something completely different. I can get it apart. This tube box is just disintegrating. I'll just replace it with a generic black, gray, white one. Well, it is a green GE. 6AW8. Looks like it's higher. See how black that is? It could be just that coating on it. There you are. But I'm not sure. Let's check it. This time I'm going to put the tube in. So we're doing the, I think this is the Pinto section, I think. Check up your shorts. Line adjust is okay. Bring it up just a skosh. Alright. Okay, well this one's checking really good on the 2103 side. 2301 I meant. It should be 2500, and it is pegging out at 3000 plus, so that's really good. I like that. So let's change this to 7986.3. 7986.3. I think this is the trios section, or vice versa. I don't remember. All I know is I'm just testing stuff. Let's check it for shorts. No shorts. Ooh, lordy, I had that on the wrong scale. Okay, got the unit turned on. I've got my who makes a stupid thing? I forgot. Yeah, I'm that crazy. Anyway, Marconi Instruments. I can't ever think of nothing anymore. Anyway, this is a Marconi Instruments TF230 floor FM AM modulation meter. So right now it's set up on AM modulation at 30%. And right now I'm set up for 30% modulation here. And I'm pegging out just a little bit on the 30, which is on the bottom scale here. So I'm going to bring it down here just a little bit. It's not far off. Remember, as I change levels on this, it would affect the readings on that. So now I'm changing it. See, it's stable now. So what we need to do now is we need to recalibrate this for 30, and then we'll come back and we'll check this again. So give me a minute. Alright. Maximum carrier set, modulation 0 set. Set attenuator vernier pot. Let's see, attenuator vernier, this one here. Let's see, fully clockwise. Modulation selector, external AC. Alright, connect model 410A AC probe to output termination, solder tip, Says here, solder tip 410B AC probe. I used to have that AC probe and meter that was attached to, but I don't have anymore. Clip ground end of probe to skirt of connector, insert connector in the output connector out. Set range, switch to band 1. See box of schematic for band. Turn frequency dial over the band of moderating. I'm trying to figure out what the hell they're doing here. Set modulation selector switch to CW, adjust maximum carrier set. You know, I don't really want to do that. Let's just skip that step. Let's set percent hang on. Sorry, it's just so much drama going around in my household. Look, I don't really have what I need to do this first maximum carrier set, modulation 0 set. I'm going to forget that. Let's set the percent modulation meter. Set frequency to 1 megahertz. I've got it on 10. I don't know why I have to set it on 1, but we'll set it on 1. I don't care. Let's see, here's yeah, I gotta go down another band. There's 1 megahertz. Okay, 1 megahertz more or less, right there. Okay, so meter sticks a little bit. Set modulation selector internal 1000. Okay. Alright, attenuator 1 volt range. Attenuator 1 volt range. Of course, that don't like it. Vernier 1 volt. Meter hangs up just a little bit, but I believe that's 1 volt. And let's see. Modulation amplitude meter 50% on. I need to attenuate that just a little bit. It's showing low. Got it on 100%, which is here, so it's showing about 62%. But I don't know if I trust it because it's not seeing the level that it likes. So let me get an attenuator. Put an attenuator on there. Yeah, so people don't know, you can take a type-in connector and put it in the jack of a BNC and it'll work. It ain't perfect, but it'll work. I'm trying to get a decent signal that this thing likes. Well, hell, that's too much attenuation. We're just gonna put it right there. Anyway, make up your mind, dude. I'm trying to figure out why this thing is being crazy. Anyway, there's 50%, it's showing 40%. I'm looking at the output here. It's output. I ought to hook this up to an oscilloscope. Let me get another BNC cable and I'll be right back. Alright, it says here I've got the output of the generator. I've got the output of the generator going out to through a BNC T, and one of them going over to the oscilloscope, the other one's going over to the mod meter. Anyway, what it does is we have the pattern here. It says put it on CW, which it is. Adjust the sensitivity control on the oscilloscope until the pattern is exactly 4 centimeters high. So, okay, so let's go up. So 1, 2, 3, 4. There you go. Alright, do not use the 3 volts range of the 606A. Switch to modulation selector to internal 1000. I'm going to get on the other side of you. Internal 1000. Alright, now set percentage modulation meter to 50%. The modulation amplitude control. It says here the pattern on the screen now should be 6 centimeters high at the peaks. So what we got? 1, 2, 3, 4, 5, 6. Just slightly high. Alright, so set percentage modulation meter to let's see, 6 centimeters at the peaks, 2 centimeters high at the troughs. So right a little bit more, so it's a little high. Pattern not exactly 3 times as high at the peaks as trough. Adjust the modulation amplitude control until it is. So let me get a modulation amplitude control adjuster. Let's find the modulation amplitude control. Sure, I got that on 50. Modulation amplitude control. Modulation amplitude control. Okay, where the hell is that? Just modulation. Okay, that would be this one. It says here. So I need. That's what I need. 2 centimeters. Let's see, 6 centimeters high, and 2 centimeters right there. So there we go. That is exactly what they're looking for. So, so that means the 606A is now modulating exactly 50%. That's what it says right here. So let's adjust the mod cal R67 until the modulation meter reach 50%. Which we had. So this is showing 50%. So that's 1, 2, 3, 4, 5, 6 centimeters high. Then the troughs are 2 centimeters, and that's exactly 2 centimeters. So according to that, that is correct. Alright, now we're going to set the attenuator vernier. So we're going to put this back on CW. We're going to go down in, let's see, to 0.2 volts. Okay, let's do this again. I want to do this one more time. I'm going to do it right. I'm going to go to the 1 volt for the attenuator. Alright. Through with this meter. Alright, there's 1 volt. So let's readjust this. Let's do it right. Let's see, going to readjust this. Let's see. It's 4 centimeters high. Oh, let's do that. 1, 2, 3, 4. There you go. Now I'm going to do it again. This time the difference is I set it for exactly 1 volt out, like it said in the first place. Alright, so 4 centimeters high, switch modulation to internal 1000, which I have. Alright, internal 1000, set percentage modulation meter to 50%, which we do. Alright, the pattern on the screen should now be, again, 6 centimeters high. 1, 2, 3, 4, 5, 6, and the trough 1, 2. Wow. That's good. I think that's good. Let's take this away. I'm just varying it a little bit. Just giving it. I'm just changing the output level here. I'm just wanting to see. I got it on CW again. I want to do this again. I'm changing the output level. Remember when we changed the output level before that the mod changed? So, adjusting it for 4 centimeters. 1, 2, 3, 4. Now we're going to go back. 1 kilohertz. We're going to set the percentage modulation as exactly 50%. So this should be 6 centimeters high. So 1, 2, 3, 4, 5, 6. Which it is in the trough. 1, 2 centimeters high. Well, look at there. I think that's right. Playing with it. Woo-wee. So, I'm going to play with this a little more off camera so I don't sound like a babbling idiot, which I think I might be sometime. Make sure this is working fine. The mod meter doesn't quite match, but I can't get the levels right because it's got such an infinite little level that it's got to see before it's accurate, and it's not doing that. But this did not do this before when I did this test. When I changed the voltage, the output level down with the vernier control or whatever, that's where it went to crap. I would set it at one level, then it'd be off on another level. So I think it's doing fine. So let me play with this a little bit and make sure it's good, and I will bring you back. Okay, one thing, I believe we have this thing fixed. This is the scope reading right here, and it's pretty close. You're supposed to be 6 centimeters right here, so here's a 1, 2, 3, 4, 5, 6, and then 2 on the trough. That tells you it's 50% modulation. And the service monitor is roughly agreeing with this. However, this thing is not calibrated. This guy here, it doesn't know what world it's in sometimes. The other thing that you'll notice is this has to be calibrated or terminated into a 50 ohm load for it to be accurate on not only the RF output but also the modulation. So what happens when I unhook this termination right here? Watch what happens to the mod. Did you see that? Goes up. I'll plug it into this, which is terminate 50 ohms. Goes back normal. So I need to get me about a 3 dB pad for this. So a little 50 ohm pad for this, just to put right here. That way, no matter what I do here, this will be accurate. So, but I think it's working. So let me turn that camera off. So it was a faulty 6AW8 tube. just happened to be the one that replaced the problem that I had to begin with that intermittent output mess. Let's see, which two was that anyway? Where is my notepad? It is disappeared. V8. See, it was the differential amplifier right here. This guy, that was the one causing the problems. That was the problem, and it was weak, seeing it was not able to handle the load when you changed the RF output. So anyway, I think it's fixed. I'm happy with it. It's as close as it's going to get. So there you go. I got yet another piece of test equipment finished till it breaks again. But I'm happy with it. I'm good. So zoom you out a little bit. So anyway, I appreciate you guys hanging in there. You know, I just got a wild hair up my butt. Thought I keep looking at that and like, I don't want to do that. I don't want to do that. Well, I said, you know what? I got enough time. Let's fix this thing. So it's done. So when it turned out to be stupid tube I put in there to fix another problem was bad. Figures. Then my replacement I bought on eBay was bad. So I wound up putting a GE tube in there. GE for the win. Anyway, I'm good. I'm gonna leave it alone now. I'm gonna put it back together, make sure it works one more time before I put it up, and put this big 40-pound sucker back on my bench and move on. Let's go fix something. My parts should be in for the television, the Zenith 17D25, and also the parts should be in for the HP voltmeter. So guess I better mute that music or I'll get a copyright strike. Thank you. Got some boom boom going out there. Had a really close lightning strike just a little while ago. Where was I? Oh, yeah. I finally got the 3,425 screws back in this thing. 3,425 and a half screws, according to Mr. Spock. Anyway, got it all back together. Got it set to, where am I at on this thing? I've got it at 3 megahertz out. Got it on the scope, and I got to rummaging around. I actually had a 50 ohm terminator right there. So what I'm going to do is I'm just going to leave this BNCT on here, and anytime I want to use this, we'll just leave that on there. Now this thing is forever accurate. Anyway, it's still set for 50% modulation. Alright, so there we go. We have 1, 2, 3, 4, 5, 6 centimeters on the peaks, and they got 1, 2 centimeters on the valleys. And that is exactly 50% modulation. Good enough for this thing. Now, let's vary. I want to vary it. Let's recalibrate. I varied the output. I'm going to do it again. We're going to turn it on 50%. 50%. And look at there. Still the same. 1, 2, 3, 4, 5, 6. And then 1, 2. So there you have it, guys. It is finished. Good enough for me. Like I say, I'll just leave this on there. It is forever accurate. As accurate as it's going to get. So let me put this thing back together, get it back on that bench, and go get a dome peel, some dome peels for my back, and because that thing ain't light. And we're done. Thanks for watching. Bye.